Okay, let's do another problem. A diesel engine adiabatically compresses an air-fuel mixture. You see, in the earlier class I told you, the class before that, I think, the working of your car engine. You see, during the time the fuel-air mixture is compressed, the compression actually happens adiabatically. There is no heat get added from outside during that time. The heat gets added only when the spark plug produces the spark and the explosion takes place. So the compression of the mixture is an adiabatic compression, and that's the reason why the temperature increases. Remember, an adiabatic expansion produces cooling, and adiabatic compression produces heating. Alright. A diesel engine adiabatically compresses an air-fuel mixture from its initial volume at a temperature at atmospheric pressure and a temperature of 25 degrees to 1/20 of its initial volume. So inside the cylinder, the piston moves so that the initial volume V1 now is compressed to 1/20th of its initial value. So tell me, what does that tell you in order to solve this problem? It gives you a very important quantity to solve this problem. It gives you V1 over V2. What is V1 over V2 in this case? It is 20. That's right. So P1 is 1 atmosphere. T1 is 273 plus 25, that is 298 Kelvin. V1 over V2 is 20. Okay. Gamma is 1.4. We consider air to be diatomic. Alright, what are we supposed to find? What is the final temperature and pressure? Well, the method is the same. To find the final temperature, we take the equation that contains the temperature. What is the adiabatic equation that contains the temperature? T V to the power of gamma minus 1 is a constant. So we pick that equation. And what does this equation mean? It means T1 V1 to the power of gamma minus 1 equal to T2 V2 to the power of gamma minus 1. And we need to write this equation so that it contains V1 over V2. You know how to do that, is that right? T2 divided by T1 is V1 to the power of gamma minus 1 divided by V2 to the power of gamma minus 1, or T2 divided by T1 is V1 divided by V2 all to the power of gamma minus 1. We know T1, we know V1 over V2, we know gamma, therefore V1 over V2 is 20, gamma minus 1 is 1.4 minus 1 is 0.4, and 20 to the power of 0.4 is 3.314. Therefore, T2 is T1 times 3.314, and that is 3.314 times 298, that is 988 Kelvin. So inside the engine of your car, when the fuel mixture is compressed, the temperature increases to a very high value, and the pressure also increases. We're going to find the pressure now. We need to find the final pressure. How do you find the final pressure? In place of this equation, we now use the second equation for adiabatic expansion or adiabatic compression. PV to the power of gamma is a constant, and we have P1 V1 to the power of gamma equal to P2 V2 to the power of gamma, and rewrite this equation so that it is written that contains V1 over V2? What would that be? P2 over P1 equal to V1 over V2 all to the power of gamma. There you are. And now V1 over V2 is 20, gamma is 1.4. That is 20 raised to the power of 1.4. That is 66.3. Therefore, P2 is 66.3 times P1, and P1 is 1 atmosphere. Therefore, that final pressure is 66.3 atmosphere. Now look at that. Inside the engine of the car, or this is actually the case of a diesel engine, which is normally used in trucks and buses and so on. So when the fuel mixture is compressed to 1/20th of its initial volume, the temperature increases almost 3 times and the pressure increases, you see that, 66 times. The pressure and temperature increases to great values, and it is at this high pressure and temperature that the spark is produced. Well, a diesel engine does not have spark. This high pressure is enough to produce the ignition. There is no need for sparks. A petrol engine has spark plugs to produce the spark, to produce the explosion, to produce the energy, so that the energy is supplied to the crankshaft. But diesel engines do not need the spark plug. The temperature and pressure will be so high when you compress it, the explosion will happen automatically. Alright, now we have done very many representative problems in adiabatic expansion. Well, please do all the homework and get back to me if you need help. There is one more lesson left in this Unit 2 in thermodynamics. Well, we are picking and choosing the topics so that we can accommodate different types of units in making up the course. All right, we will do one more lesson for thermodynamics and then go on to electricity later on. I will see you for that last lesson later on.